Great having you on the podcast. How are you today?
Likewise, Jared, thanks for having me. Excited to be here.
I wanted to kick things off right out of the gate. We're going to tag you and everything. People will be able to learn more about you if they're just getting to know you. You've been in this space for a while. Intel, now Blaize. For our listeners who may be new to this term, I would love for you to kick things off today with how do you define physical AI?
Great question. Let me contrast it with all of the AI that's happening currently in the data center as we know it, like Google, Facebook, etc. All the wonderful work that OpenAI is doing in ChatGPT, etc. That is the data center AI. Now, when you step outside the data center into real world applications, it could be things like how do you make your cities safer with cameras on the street? How do you make manufacturing more efficient with better inspection of for quality control? How do you make your perimeters of a country safer with applying cameras and different sensors? Agriculture productivity, how do you improve it? All of these are real physical world problems, and AI is now being applied to these use cases, and that's what we define as physical world AI. And to contrast, the amount of data they say is the fuel for AI. And if you look at deep data center, the amount of data outside in the physical world in all these domains that I mentioned or industries, there's about a 1 million times larger amount of data, and it's untapped, undertapped, and that is where Blaize is focused. We have products to help with that.
And it must be really exciting for you when you hear more about this term physical AI more than ever before, right? In the even over the last couple months, it's been a very heavily used term. Specifically, what a lot of people will point to is at the GTC and also Intel's Vision conference, both spotlighted physical AI. Can we talk a little bit about why is this concept exploding now? And then I guess really what's changed over the last 12 to 18 months that made all this possible?
Absolutely. So let's look at it this way. The availability of data, the ease of use, and then the availability of AI models. These are like three growth drivers. So first of all of these industries, they're built on they're running better factories, safer cities, applying it to defense, education, manufacturing, healthcare, etc. They have their practices. So a technology should be solutionized to impact these industries. So there's an element of a processor which is efficient for these use cases, which is required. It can't be, in the data center, it's largely GPU based, which is focused more on heavy compute. More out, especially in the physical AI, the processor needs to be lower power, lower, and because these are battery operated, it needs to be lower latency because a car is driving at a high speed and needs to make a decision real time. The ease of deployment is very critical, right? Because often these people are they're not AI experts, but they know that applying AI, their productivity can be improved or some value that can be derived. So the additional software layer to make it simple and a solution to be adopted. This is the recipe book that is required to make AI into this physical world. Now, to add to that, compute is actually is becoming more real and affordable for AI into these physical world applications, right? A good amount of compute packed on chip. The other piece is the shrinking of AI models, right? This is a major thing that's happening over the last 18 months. DeepSeek is one of them. But every major AI model, be it the Llama from OpenAI or others, or DeepSeek's own, or every company that's building it, the point is that uh, it is there's a 600 billion parameter largish model. There's a small model that can actually be fit onto edge chips, and those models are almost as efficient as the larger counterparts. So what you're seeing here is improved AI models that can run in a physical world setting, achieving a high amount of accuracy and creating some value, right? So all of these pieces are happening together, and that's the growth driver.
Now, I want to highlight a couple things because that you mentioned in there and that we're continuing to hear in the news and everywhere else, specifically around chips. So let's talk chips and specifically how Blaize is approaching edge AI differently than the traditional players like NVIDIA or even your old home Intel.
So specifically chips, we have a very foundational architectural innovation. So let me, at Blaize, what we do is we have a foundational processor called graph streaming processor. Essentially, all of these AI workloads, they're a different kind of compute than graphics. Right? GPUs were historically built to run games and graphics, and absent of a dedicated processor, AI is being run on them, but they're not the most efficient. At Blaize, we've purpose-built an architecture which is suitable for AI, and that makes it more efficient, lower power, modest cost, and lower latency. All the benefits that we bring to the table. That is the specialty at the processor level. Now, the processor alone is not enough, right? Because of the knowledge gap. So we went above and beyond. We built a software layer called AI Studio, so that the customers can experience a code-free platform, right? Like similar to the Macintosh. You have efficient hardware and easy-to-use software, and that makes AI come to life at end customers. We do partner with third-party software, companies whose software runs on Blaize's chips to create value-added solutions. It could be for monitoring in a defense setting. It could be in a safe city monitoring, different cameras in the city for different anomalies, etc. Various use cases. So making the whole platform flexible, easy to adopt, and add an ecosystem of partners will make the technology easy to adopt in all these applications. So that's at the processor layer. That's our advantage.
Can you walk me through, a few real world examples where physical AI is already making a big difference? I don't want. I'll let you pick, but like specifically maybe healthcare, automotive, smart cities, to name a few. But would love to hear real
Sure.
world examples.
Automotive, it's already being utilized. Automotive is a good industry because they're building cars now that has to get into production into 2028 and 2029 timeframe. So they're taking a very long-term view. Now, AI is being applied for everything from a class of, in autonomous driving, there is level two, three, four, right? Different levels of autonomy, and each car maker has a different time horizon. But the idea of how they're applying AI to benefit their customers, right, and of course monetize also, this is a very real thing that's happening. If you, for example, buy a car nowadays, you pay for the car, but then you also pay a software subscription for a self-driving capability, right? Guess what? Those computes are actually running on an AI processor. So AI is very important for those class of use cases. How money is being made in automotive, right? That's one. Also, it's being used for other things like battery management. How do you make your battery last longer? Different use cases within the automotive industry. Within the automotive industry, manufacturing is getting AI, right? How do you apply AI to make it more efficient in terms of manufacturing and so on, cost efficiency, etc. Now, the other use cases like safe cities, let's take it, right? Safe cities as an example. There are about three classes, right? Right now, there's about 1 billion cameras installed worldwide. And these cameras are essentially dumb cameras. They're recording devices. There's no intelligence. AI is being applied for three reasons, right, at a high level. One is revenue generation. What you have here is how do you potentially issue traffic tickets, right? For you may not like it, but maybe if you jump a red light, automatically recognize your number plate, right? That's revenue for the city. Other thing is safety, right? Having uh, visual inspection of a potential crime or and so on, right? Crime prevention, etc. The third one is also energy savings. If imagine people are not there in a certain area, can you dim down the lights so that you save energy and so on? So different use cases applied to safe cities. Same similar use cases in other industries, right? The AI models are same. You can apply it to. So these are actually things happening right now, right? And since you asked about what's happening right
How do I get out of the ticket if the AI says I crossed the red light? Are there going to be any hacks from you to be able to help with that? Say, oh, it was during a software update or something like that. What's going to be the way to get out of it?
how about we make it something even better, right? We prevent it, right? We'll warn you that, hey, look, you got to slow down, there's a red light coming in there, and you don't want to get a ticket, so better slow down right now. So we'll make it even better.
I'm all for that. Yeah, it's one of the ways when Waze came around, just kind of telling you, hey, there's a you know a light ahead or something like that was pretty cool. Um, it's super interesting, and the use cases are actually they're almost endless, right? There's a
Yeah.
bunch. Just the light one that you mentioned too. Just being able to see like if there's no people in a certain area, probably it doesn't need to. Those lights maybe don't always have to be on, right? Too,
Right.
until there's more populated people or even just a couple people, right? We don't want dark zones. That creates bad actor areas, right? If
Mhm.
it's just a really no light situation. Um, I want to talk a little bit about you have several customers in proof of concept stages with you right now. What kind of challenges are they solving for, and what's been getting them excited?
So we have a solid pipeline of about 400 million. And the way we try to pick our customers are beachhead customers, essentially, meaning that within that customer, we're perfecting a use case. And once we perfect the use case, there is a land and expand within that customer as well as across an entire sector. So to answer your question, these customers they pick a use case that they want to solve, and with a clear return on investment, right? We call it proof of value within Blaize. But the idea is that hey, utilizing Blaize chips and software, how can you actually solve this problem, right? That's the main, and we go after it and we prove it to the customer, and of course that leads to next steps and so on. So it could be, for example, in an airport, right, baggage handling. There's almost like a close to $1 billion worth of fines airlines pay to for mishandled baggage and so on. Applying AI, you could actually not lose the bags and not pay the fines. That's a clear savings for the airport and the airline. So the proof of value there would be how you reduce, over a period of time, either delayed baggage or mishandled baggage, right? And once customers see that, they're like, "Whoa, oh, we got to take this and deploy it," right? So that's an example, right? But in each industry, there is a certain use case. The commonality for Blaize is that most of these use cases that we are going after, there's a video or an image, computer vision, those class of problems. So that for Blaize, it's like a programmable platform that we build, hardware plus software libraries that enable such use cases. And then we partner with the ecosystem.
I want to talk a little bit about some high stakes environments like defense and autonomous vehicles, right? Um, Seems like we've been hearing a lot about autonomous vehicles, especially as of late. Edge AI is especially critical for real time decisions. So, can you give us a quick peek into how that's playing out into those high stake environments that I just named?
Sure. So let's talk about each separately. Automotive, we've touched upon autonomous driving and so on, right? And so that is a very clear you cannot get it wrong kind of a thing, which means that and of course there's levels of autonomy, right? But the idea is in a very low latency manner, right? In a fraction of a second, milliseconds or fraction of milliseconds, you need to detect what's in front of you and either go around the obstacle or slow slam your brakes, or to your point, right, don't get the ticket and slow down way ahead. um, the safety use cases, and for that, it's of course the chip and the software, but also automotive industry has a lot of safety practices. They call them ASIL, etc. But essentially, how to make the platform safe. Redundancy in the platform is, so that it's foolproof. And so there is an entire set of practices that are happening in the auto industry to make this all happen. And we work closely with our partners there. Switching gears to the defense industry, an example is having imagine a battlefield where you have 10,000 cameras, sensors, drones, satellite imagery, different kinds of signals coming in, and you're in a moderately disconnected environment. So all of these are getting piped back to a command and control center in local vicinity. It's impossible for one human or even 10 humans or 100 humans to look at this constantly and identify what's happening. But having a server, an AI server based on Blaize, running real-time software, right, looking for anomalies. Hey, there is a fire in this zone number 33. Do you want to send in a reinforcement, right? All of this AI driven, real time, and making it happen. Like those are some of the use cases. So, and also there's this concept of multimodal AI that's evolving. So the AI models that are happening are fusing language models, vision models, uh, text, everything together. And because Blaize is a programmable processor, we're able to adopt these things with ease, as opposed to respinning silicon. So we're well positioned for this multimodal AI, and this is going to be a very key growth driver in all these use cases that I mentioned.
Where do you see this area going in the next 2 to 3 years? And is Edge AI just a chapter, or is it really the next platform shift?
The latter, for sure. Uh, all of the work that was done in the cloud, the natural extension is for that to come into the edge. I mean, we've seen this before, right, with the advent of IBM mainframes moving to PC, right? And that led to massive amount of computing in all walks of our life. AI will see a similar trajectory. It started off deep in the data center in the cloud, and with the shrinking of AI models, making models better, true multimodal AI, meaning that capturing different kinds of AI signals and different types of AI, making them a single model, and and doing all of this in a affordable compute, right? Affordable, not just at the chip level, at a complete solution level, and making it very real. All of these things are happening, and the test is that these industries that are taking to AI, they need to see a clear value, right? Because these industries are not technology companies. Largely, they're if anything, they're either industrial companies, they're defense companies, they're etc. But there has to be a clear value, right? It's either making things safer, it's either reducing their capex spend or improving their operational expenses or whatever, right? Each company has their metrics. So if you're able to meet those, then it's a very clear decision for them to do it. There's also the competitive angle, right? Some of these industries, there's a massive competition, right? And if, let's say, I don't do it, but my peer does it, then I'm going to be left behind, right? We see that also happening. So all of these are going to help AI adoption, and the growth is going to be, I think, phenomenal. I think more exponential than not.
Last question for you before we wrap up. For builders, startups, or just anyone that's curious listening, what's one thing they should be watching or doing right now if they want to be a part of the physical AI wave?
getting ahead and experimenting and actually doing it, right? Because there is this one opportunity right now, which is it's a time opportunity, time window, right, where things are just happening, and if you wait too long, then you'll have missed the curve. So, if of course entrepreneurs or even builders or whoever, they have an idea, now's the time. And fortunately, the technology is here, and with the shrinking models and technologies like Blaize, which are easy to deploy and ready to deploy, all of these exist. So taking advantage and actually just taking just going and trying it, making it happen, I think is uh, is the thing I'd recommend.
Well, I want to thank you so much for joining me here today. This is going to go down as one of my favorite episodes that I have done with this show by far. You were great into diving into all of these topics and teaching the audience a lot. So thank you so much for joining me here today. I really appreciate it.
Thank you for the opportunity, Jared. Enjoyed likewise.